everybody. Welcome back to our series on Vertex Operator Algebras. In today's episode, we'll investigate the proof that the operators we constructed last time form a representation of the Virasoro algebra. First, let's review the ingredients used in the claim. Let H be an abelian Lie algebra, and remember our extended affine algebras of both twisted and untwisted type. In either case, we consider operators associated to these elements on the Heisenberg module S of H hat Z minus. Incidentally, H hat Z, the untwisted Heisenberg algebra, is the commutator subalgebra of Virgulia H. Similarly, H hat Z plus 1/2 involves the twisted case. Our claim is that the bracket of Lm with Ln is a central extension of the Witt algebra, with the specific term, the dimension of H over 12, quantity m cubed minus m. Proof. First, let's consider the bracket of Lm with some generic operator, hm, and we'll show that it equals minus n h of m plus n. Plugging in the definition of Lm, we now compute the bracket. Given that result, we now show that for m plus n not equal to 0, we recover the typical Witt algebra result. To that end, we can once again compute the bracket with our new known results. Good. So finally, for m plus n equal to 0, but n non-zero, we investigate the last bracket, L of m with L of minus m. Following FLM, we express L of minus m by splitting the sum into two parts. Observing, of course, that for non-zero m, the two factors of h sub I commute. It's not hard to show by direct computation that this bracket equals twice L of 0 plus some remainder, which we proved in section 21 was equal to c over 12 m cubed minus m. Which means that we're almost, but not quite done. We still need to verify that c is equal to the dimension of h, which we will do next time. And we'll show how they're related to some extra details of those Heisenberg algebras.